lecture number 3, we are going to discuss the next method, that is Lagrange's interpolation method, and we are going to see one more formula, that is trapezoidal rule. Okay, so firstly we'll see what is Lagrange's interpolation. Okay, if the values of x are not equispaced and the values corresponding to that x, if the values of y are given, then Newton's interpolation formulas are not useful, and that type of problem can be solved by using Lagrange's interpolation. Okay, so it can be used for any arbitrary specified points. Or we cannot use Newton's or ln, it is generally denoted by L suffix nx passing through the points x0, x1, dot dot xn is given by ln x, and the formula for that is x minus x1 into x minus x2 dot 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 x minus xn divided by x0 minus x1, x0 minus x2 dot dot x0 minus xn into y0 plus x minus x0 into x minus x2 dot dot x minus xn divided by x1 minus x0 into x1 minus x2 into x1 minus xn into y1 plus dot 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 x minus x1 into x minus x2 into dot 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 x minus xn minus 1 divided by xn minus x1 xn minus x2 dot dot xn minus 1 into yn. Okay, so this is the formula by which we can get the Lagrange's polynomial, and for whatever value of x we want to find y, put that value of x here, put the tabular values of x0, y0, x1, y1 in this, and doing the calculation we can easily get the answer. Here we doesn't need to form any table. Directly putting in this formula we can get the answer. How to remember this formula? Okay, it seems to be lengthy, but if you remember the technique, then you can easily use this formula and solve the problem. What we have done, what is this first term? We have taken x minus x1, x minus x2, x minus xn. So except first term, except x0, subtract all remaining values of x from x. For finding the first term, subtract all the values other than x0 from x and divided by, take the subtraction of x0 with all the values of x. Take the subtraction of x0 with all the values of x and multiply with the corresponding value of y for x0, that is y0. Okay, take the subtraction of x with all the values of x other than first term divided by first term minus subtraction with all other values of x into first value of y. Plus, for finding the second term, what to do? Take the subtraction of x with all the values other than this second term x1. Okay, divided by x1 minus rest of the terms. Replace this x by x1 and multiply with the second value of y, that is y1. Like that, continue. And if there are n terms, we get the addition of such n terms. Okay, here 0, 1 up to n. So these are total n plus 1 terms. Okay, so that much addition of that much terms we have to take. So it is very easy. If you remember this format, you can easily get the solution. Just simple multiplication and calculation we have to do to get the answer. Now, this equation is y in terms of x. Whenever we want to find the value of y at some x. But if you want to find the value of x for some value of y, then how to get that? For that, we use the inverse Lagrange's interpolation. Now, how to get this inverse Lagrange's interpolation? Just interchange x and y. Whatever formula we saw just now, in that formula, interchange x and y. So x ln of y will be, take the subtraction of all y terms except first term from y minus y1, y minus y2, y minus yn. Then replace y by y naught. Take the subtraction of y naught with remaining terms and multiply with the first value of x, that is x naught, plus subtract all the values of y except second term, that is y1, y minus y naught, y minus y2, like that. Take the subtraction and divide it by y1 minus all rest of the terms into x1 and continue like that. We get this term y minus y naught, y minus y1 up to y minus yn minus 1 except yn. Take the subtraction of y with the rest of the terms divided by yn minus subtraction with the rest of the terms into xn. Okay, so these are very easy and very important formulas. These formulas can ask for multiple choice question also, inverse in Lagrange interpolation or direct Lagrange interpolation. Okay, no derivative, nothing, just simple formulas and simple calculation, just multiplication and addition of the terms. That gives us the answer. Okay, now we'll take the problems based on it. Using Lagrange's interpolation formula, compute y of 1 from the following table. Values of x are -1, 0, 2, 3, and the corresponding values of y are -8, 3, 1, 2. Okay. Now, if you just carefully look at the table, the difference between these two is 1. Difference between these two is 2. Difference between these two values is 1. So the difference between these values is not fixed. So we cannot use Newton's interpolation formula, because we can also find the value of y for a given value of x by using Newton's formula. But when the difference between the values of x is throughout same, they are equispaced, then only we can use Newton's interpolation formula. But here it is not such case, so we are using the Lagrange's formula. This is the value of x naught. First value is x naught, second is x1, x2, x3, like that. These are the values of y naught, y1, y2, and y3. Okay, so the Lagrange's polynomial will be containing 4 terms. The first term will be x minus, take all the rest of the terms, x1, x minus x2, x minus x3, and divided by, subtract all the values of x from x naught. X naught minus x1, x naught minus x2, x naught minus x3 into first value of y, that is y naught, plus, except second term, take the subtraction of all x from x. So x minus x naught, x minus x2, x minus x3 divided by, now take the subtraction of second value with all rest of the values of x. x1 minus x naught, x1 minus x2, x1 minus x3 into second value. Take the subtraction of all term except third term from x and replace x by second term x2 and multiply it with the second value of y, that is y2. There are 4 terms, so we get the addition of these 4 terms. Take the subtraction of all x other than fourth value from x and replace x by the fourth value. Fourth value is x3. Okay, and multiply with the y3. Okay, now we want to find the value of y at 1. So this is the value of x. X is 1, x naught minus 1, x1 0, x2 2, x3 3, and y naught is -8, y1 is 3, y2 is 1, and y3 is 2. Okay, so these are the values given in the table. Now put this value into the standard formula. Okay, we are taking x as 1 and now doing the substitution. Simple substitution is there. Take the subtraction, addition of the corresponding terms, and that gives us the answer. So y at 1 will be 1 minus 0, 1 minus 2, 1 minus 3 divided by -1 minus 0, -1 minus 2, -1 minus 3 into first value of y, that is -8. Like that, substitute all these values into that Lagrange's polynomial. So simplify it. Simple calculations are there. You can easily do that calculation. And you can see all this term comes out to be 1.333 plus 2 plus 0.6667 minus 0.3333. And then simplify it, get the answer. So value of y at x equal to 1 is 3.6667. Okay, so it is very easy. No table we required. This is more general method. Actually, all the problems, whether it may be equispaced or not equispaced, we can use this Lagrange's method. Okay, there are restriction for Newton's interpolation, but there are no restriction for Lagrange's method. It can be applied for any number of any type of terms. Okay, consider the next problem. Using Lagrange's interpolation formula, compute y at 2 from the following table. Values of x are 0, 1, 3, 4, and values of y are minus 12, 0, 6, and 12. Again, do the same thing. First, write down the Newton's Lagrange's interpolation formula. As there are 4 terms, we get the addition of 4 terms. If there are 3 terms, we get only 3 terms. If there are 5 terms, we get addition of such 5 terms. Okay, x minus, except first, take subtraction with all rest of the 3 terms. Then first term, subtraction with the rest of the terms into first value of y, that is y naught, plus consider the for second term, take subtraction of that x from all the rest of the terms and subtract second term from all the terms into second value of y. Okay, do the same thing for the other 2 terms. Okay, very simple formula. If you remember how these terms are coming, so you can easily get this formula. Okay, at a time means for finding first term, take the subtraction with rest of the terms. Okay, and by doing that we get this formula. Now from the table we know what are the values. X0 is 0, x1 is 1, x2 is 3, x3 is 4, and these are the values of y, y0, y1, y2, and y3. Okay, first value start with 0. Okay, we consider these first values at 0th value, x0, y0. Okay, don't forget that basic things. Okay, now you want value of y at 2, so x will be 2, so put x equal to 2 and these values of x0, x1, x2, x3, all these values into this formula. So these are the values which we got from the table. x0 is 0, x1 is 1, x2 is 3, x3 is 4, y0 is minus 12, y1 is 0, y2 is 6, y3 is 12, and x at which we want to find y is 2. Put all the values in the formula. Simple calculation, just multiplication and addition of the terms. So you can easily do this calculation and get the value of y at 2. So y at 2 will be 2 plus 0 plus 4 minus 2. 2 to get cancelled. So the value of y at 2 is 4. Okay, so very simple and very easy calculations are there. Properly remember the standard formula. Okay, and notation for each term. First terms are denoted by x0, y0. Last term is x and y, and proper subtraction and simplification gives us the answer. Okay. Next, consider the next problem. Using inverse Lagrange's interpolation formula, compute x at 8 from the following table. X is minus 2, minus 1, 1, 2, and values of y are minus 7, 2, 0, 11. Okay. Now, here it is asked to find x at 8, that is value of y is 8, and we want to find x for that value. Okay, and so we have to use the inverse Lagrange interpolation. If it is asked to find a value of y for given value of x, then we use the regular Lagrange interpolation. But if it is asked to find a value of x for given value of y, then we use inverse Lagrange. And inverse Lagrange means just interchange the values of x and y. By that we get the formula. Okay, so no separate formula, it is one and the same. Just we interchange x and y terms. Okay, so what we do, subtract all the values of y except first from y minus y1, y minus y2, y minus y3, divided by subtract all the values of y from first value, y naught minus y1, y naught minus y2, y naught minus y3 into first value of x, that is x naught. Okay, so we are just interchanging x and y from the in the basic standard formula of Lagrange interpolation that uses the formula for inverse Lagrange interpolation. Do the same thing, get the second, third, and fourth term. Okay, so it will be, for second term we take the subtraction of all y's except second term from y, and denominator will be subtraction of all terms from the second term except second, subtraction of all the terms from y1 into x1, and by that same way we get the rest of the terms. As there are 4 terms, we get the addition of such 4 terms. Okay. Now from the table, write down what are the values given to us. X0 is -2, x1 is -1, x2 is 1, x3 is 2, and values of y are y0 is -7, y1 is 2, y2 is 0, and y3 is 11. Okay, so put that values into it. So use all these tabular values. X0 -2, x1 is -1, x2 is 1, x3 is 2, y0 is -7, y1 2, y2 0, y3 11, and x4 is we want to find the value of y at x equal to 8. So we are taking that x equal to 8. So use the Lagrange polynomial. Just do the substitution, putting all these values into the formula and do the calculation. Simplify it and do the calculation. So value of x at y equal to 8. Sorry, this is y equal to 8. Putting y equal to 8 into the formula. So value of x at 8 will be all these terms. To the simplification, calculate all these terms. So x at 8 will be -8 by 21, -20 by 9, -135 by 77, plus 80 by 99. And if we simplify it, calculate the value, it comes out to be -3.5483. Okay, so these are the different ways by which we can find the values of unknown terms from the tabular values: Newton forward, Newton backward, and Lagrange's interpolation formula. Okay, we use Newton's forward and backward to find derivatives also. How to get the first order and second order derivative by using Lagrange's interpolation, that also we saw. Okay, now next term is a numerical integration. There are many complicated integration which solving directly it's quite difficult, but by using different numerical techniques we can easily solve that. So what are the different techniques, or what are the different formulas by which we can get the solution? Suppose we have this definite integral from of f of x from a to b. After integrating it, what we do, whatever integration of f of x we have, we substitute upper limit of at that whatever integral we got minus value of that function at lower limit. This is how we solve the integration. But if this is difficult, then how to solve this? So computing this definite integral, okay, many times it is difficult. So by using the tabular values, calculating this integration, we call as a numerical integration. If you know the values of f of x at different points, then making use of that points, we can solve the integration. Without actually solving the integration of f of x, we can get the value of integration. So that is the importance of this numerical integration. Now, what are that technique to solve the integration? It is also very easy. Single formulas we have to remember, and making use of that, we can easily solve the problem. Now, what are the method? Suppose we are given this integration, integral of f of x from a to b, and f of x we denote it say by y, say y equal to f of x. If the values of this function, values of this inside function at different point, uh, at different point is known. Suppose we know y1, that is the value of function at x0. Y1 is the value of the function at x1. Like that, yn is the value of the function at xn. Then, uh, what are these x0 to xn? These we get by dividing this interval a to b into n subintervals. Okay, first take this interval a to b, divide it into n subintervals. And what is the width? We take width as h. So what will be h? Subtraction of b and a divided by number of subinterval. That gives us h. So carefully remember what is subinterval, what is the width. Okay, by using this, and we are having different ways, different rules are there to find the approximate value of the integration. We are going to see three different rules. The first one is trapezoidal rule, and like that we have two more rules to find the integration. So firstly, we'll see how to get the integration by using trapezoidal rule. What is the formula? Integral from a to b y dx. You can use y or you can use f of x, because this is just another notation for f of x. Y is nothing but f of x, equal to h by 2. H is the length of each subinterval. How to calculate that? B minus a, subtraction of upper limit minus lower limit divided by number of subinterval. Generally, either number of subinterval or h is given in the problem. So accordingly, we can get these values. Okay, it is equal to h by 2 y0 plus 2 times y1 plus y2 plus dot 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 yn minus 1 plus yn. Okay, so just by using this simple formula, we can get the value of integration. Okay, how to get these values? We have to divide this interval a to b into number of subintervals. Okay, then find the values of this function at different values of x. How to find it? How we take the values of x? X0 is nothing but a. X1 will be x0 plus h, because h is the width. So x1 will be x0 plus h. X2 will be x0 plus 2h or x1 plus h. Just go on adding h to it until this xn become b. And for each value of x, find a value of this function, that are y0, y1 up to yn, and use these terms to do the calculation. Simple formula to remember. By using this, we can easily get the integration. Okay, very easy formula. By problems, you can easily understand. Means you can understand that very. This is very easy. Just simple calculation we have to do. Carefully and remember the meanings of what are h, what is n, how to get these x0 to xn, how to get y0 to yn, and by doing this simple calculation, we can get the answer. So we'll take the problem and then we'll see how to use this formula to get the solution. Integrate approximately integral 1 to 1.04 f of x dx by using trapezoidal rule from the following data. Values of x are 1, 1.01, 1.02, 1.03, 1.04. f of x will be 3.935, 4.066, 4.182, 4.300, 4.421. Okay, so values of x and f of x. F of x means y. So values of x and y are given in the tabular form, already given in the form. Okay, so we have to just identify what is h, what are the values of x naught, y naught, x1, y1, all that values, and then by using standard formula, we can get the answer. Okay, so here what we have, difference between any two values. Difference between any two values of x, that is nothing but h. Okay, this is the subinterval 1 to 1.01, and length of that subinterval is nothing but h. And this is x0, x1, x2, x3, and this is x4. So n will be 4. Okay, total number of subinterval is 4. This is not total number of terms. There are total 5 values of x, but n is number of subintervals. This to this is one interval. 1.01 to 1.02 is one subinterval. This to this another. This to this another subinterval. So n will be actually total number of terms minus 1. Okay, total number of term minus 1, because we do the calculation from 0 term, x0, x1, x2, x3, x4. Last term we take it as xn. So xn is x4, so n will be 4. So how to get n? Number of terms minus 1 will be n. Difference between any two terms is h. Upper limit b, lower limit a. Okay. Now, so these are the values we know: x0, x1, x2, x3, x4, and these are the corresponding values: y0, y1, y2, y3, and y4. And we know the formula, trapezoidal rule. Formula of trapezoidal rule is integral 1 to 1.04 f of x dx will be h by 2 y0 plus. Now, how many terms are there? What is the nth term? y4. So addition of first and last term plus 2 times addition of all middle terms. Okay, y0 plus yn. N is 4, so we take y0 plus y4 plus 2 times addition of all remaining values of y. Okay, put the value of h 0.01, put the values of y0, y1, yn, and all in between values, and do this simple calculation. Okay, so calculating this, it gives us the answer 0.16735. Okay, so you can see it is very easy. Just within 2 steps we get the value of the integration without actually solving the integration. But by using this numerical technique, by using the trapezoidal rule, we got the answer quite easily. Okay, so that is the importance of using such method. Okay, here f of x is unknown, but we know the tabular values of x and f of x. Okay, so this is one of the type in which f of x is not known, but tabular values of the function is known. In some of the problems, function is known to us, then we have to prepare a table, and then using that tabular values, we just have to do this simple calculation. Okay, I'll consider the problems in which table is not given. Suppose we want to evaluate integral 0 to 1 dx upon 1 plus x square by using trapezoidal rule. Take n equal to 6. Okay, in the problem itself n is given, or otherwise you can take it of your choice if it is not given. Okay, but here it is given. Either n is given or h is given in the problem. Okay, in this problem n is given as 6. A is 0, b is 1, n is 6. So from that we can get h. H will be length of subinterval, and that will be b minus a divided by n. So n will be 6. This function f of x is 1 upon 1 plus x square. Other than dx, whatever term is there, that will be our function f of x. Or you can take this as y. H will be b minus a, that is 1 minus 0 divided by n. So that will be 1 by 6. So first value of x will be a, that will be 0, and last value of x will be 1. How to get in between values? At first value, add h to it. X naught plus h will be x1. X naught plus 2h will be x2. So add 1 by 6 at every point until you get 1. So how to get x? First term is 0. Next term will be 0 plus 1 by 6. Then next term will be 0 plus 2 into 1 by 6. Next term will be 0 plus 3 into h. Next term will be 0 plus 4 into h, 5 into h, 6 into h. We have to start with a and we have to reach up to b. Okay, a is 0 here and b is 1. A is the lower limit and b is the upper limit. And at every stage, add h. H is the length of subinterval. So every step, add h to the previous term. 0 plus 1 by 6. 1 by 6 plus 1 by 6. 2 by 6 plus 1 by 6. Like that, go up to b, that is 1. Now, put this value of x into this function. Substitute x into this function. So if you put x equal to 0, we get 1 upon 1 plus 0 square. That will be 1. Put x equal to 1 by 6. 1 upon 1 plus 1 by 6 square. That will be, that comes out with 0.973. 1 upon 1 plus 2 by 6 square. It will be 0.9. Substitute x equal to 3 by 6, get the next value. Put x equal to 4 by 6, get the value. Put x equal to 5 by 6 and get the value of that function. And at the end, put x equal to 1. 1 upon 1 plus 1 square. So that will be 0.5. Okay. So if the tabular values are not given, then make use of the given function, make use of n, find h at equal interval, split this 0 to 1 into corresponding parts, and put this value of x into that function to get these values. F of x means these are the values of y term, y0, y1, y2 up to yn. Okay. Now use the formula. There are total 6 terms. So we are having up to y6. So it is y0 plus y6 plus 2 times all remaining terms. Okay. So just put these values into this formula. Y0 is 1, yn is 0.5 plus 2 times addition of all this rest of the terms. Okay. So simplify it. H is 1 by 6 divided by 2, and doing this simple calculation, addition of the terms and multiplied by 1 by 6 into 1 by 2, that gives us 0.7842. Okay. So very easy. You can easily prepare a table from these given values and given function. Okay, and making use of these values from the table, we can easily solve the integration. So important in this is remembering the formula for trapezoidal rule and how to get, means if table is given, then no problem. But if table is not given, then how to prepare a table from this integration. That is very important. And doing simple calculation, it gives us the answer. So without actually solving this integration, if you don't know what are the formulas of integration, still we can get the value of that integration.